Yes, welcome. Good morning everyone. Today is the first class of the atomic structure chapter. So we'll be starting this class. I hope all of you are fine, doing well and doing great and doing consistent effort in your exam preparation. Yesterday we have done the question paper solving or question paper discussion. I hope that was clear and perfect to everyone. So today we'll be starting the next chapter. The first chapter we have done, more concept. Hope that was clear and you are confident enough to solve questions from that chapter. And now we will be starting the next chapter, that is the atomic structure. Atomic structure, it is actually a little bit big chapter, and the questions coming from this chapter, mainly we can see the questions are coming from these topics, which already we have discussed in the orientation class itself. That is the major topic that will be coming for this is Bohr model of atom. Bohr model of atom is a very important one. And in that, radius calculation, velocity calculation, energy calculation, all these are the very important points. And the next one is the hydrogen spectrum. In that hydrogen spectrum, the Rydberg equation or formula to calculate the wavelength and total spectral lines. That is important topic in that part. Then the dual nature of light, that is the de Broglie wavelength. Then Heisenberg's uncertainty principle, quantum number, electronic configuration, stability of orbitals, knots calculation. All these are the important topics in this chapter. Now we will be discussing each and every topics one by one, and then we can solve questions and we can finish up this chapter in a very detailed way. Okay, so are you guys ready? Shall we move to the first part of this chapter? If you are ready, just put some thumbs up or some reactions in the chat box. I want all of you to be active in the class. I know it's very difficult to sit in front of the laptop and listening to the class, so I want everyone to be active in some way. If possible, you can switch on the camera so that you will be conscious that someone will be watching, and that will make you a little more focused. So whatever the things that is helping you to be focused on the class, just do that one. I will try my maximum to make you attend the class very focusfully. Okay, so let's coming to the first part of this chapter, that we will be discussing about the development that lead to the Bohr model of atom. And what are the developments that lead to the Bohr model of atom? They are electromagnetic wave, Planck's quantum theory, photoelectric effect, atomic structure. These are the important topics that lead to the Bohr model of atom. Now we can discuss the first one, that is electromagnetic wave. Electromagnetic wave is a simple one. It's nothing but when a charged particle either accelerated or decelerated, what is going to happen? Energy will be emitted, and this energy is emitted is what we call it as electromagnetic radiation. It's also called as thermal radiation. And the main thing is, what is the nature of this electromagnetic radiation? Is it wave nature or is it particle nature? That was the confusion. So first what we can do is we can see how the wave character of electromagnetic radiation is. Okay, for understanding the wave character of electromagnetic radiation, we will be going through the properties of electromagnetic radiation. Which are the properties of electromagnetic radiation? In an electromagnetic radiation, there are two fields are there. One is electric field as well as magnetic field. And electric field, if you see this graph, if you see this one, electric field is in the x direction, magnetic field will be in the y direction. Then where will be the direction of propagation of wave? The direction of propagation of wave will be to the z direction. That is one of the property of electromagnetic radiation. And electromagnetic radiation, it can travel in vacuum, and speed is, what is the speed? Speed is 3 into 10 to the power 8 meter per second. That is one of the property of electromagnetic radiation. Okay. Now these are the part that I want to take a note of it. What are the different ways in which you can represent electromagnetic radiation? First one is through wavelength, then frequency, then wave number. These are the three ways in which you can represent electromagnetic radiation. Okay. Now only thing you are note on is the relation between these. This is the important one. The relation between speed, frequency and wavelength. That is C is equal to nu by lambda, or nu is equal to C by lambda. This is important equation, and questions directly comes from this equation. So just note it down. I will give you that question also. Okay, this is clear, I guess. All these are basic things in which there is no much detail is required. Okay, now the next one is about the electromagnetic spectrum. If you look at this electromagnetic spectrum, you can see starting from gamma rays which is having less wavelength and higher frequency. gamma rays to long wave radio waves. Question will come, arrange the following based on their increasing or decreasing order of their wavelength or frequency. That was the question, that will be the question that can come from this part. Okay, so just take a note of it. Just you should remember these radiation: gamma, X-rays, UV, IR, microwave, long wave radiation. Okay, take a note of everyone. Okay, I think this is your NCERT textbook. You can just mark it on your NCERT textbook, no worries in that. Okay, now we will be moving into the actual part of this chapter. Yes, Planck's quantum theory. Before going to the Planck's quantum theory, let me tell you what lead to the Planck's quantum theory. Actually, many of the phenomena of light like diffraction, reflection, all these can be explained by taking wave character of light. But there are many other phenomena like black body radiation, heat capacity of solid, photoelectric effect. All these were not able to explain by considering the wave nature of electromagnetic radiation. So what the Planck has been done is, Planck has introduced a theory which is called as Planck's quantum theory, which is telling or explaining the particle nature of light. That is what we are going to discuss right now here. Okay, yes, Planck's quantum theory. According to the Planck's quantum theory, electromagnetic radiation, this will be radiating, right? Electromagnetic radiations are not actually going through in the form of wave, continuous, not actually flowing continuously as like wave. Then how it is propagating? It is propagating in the form of small packets. What it is? Small packets of energy. Okay, small packets of energy. That is electromagnetic radiation according to Planck it is radiating through small packets, and these small packets I can say is called as quanta. These small packets I can say it is called as quanta, and a single packet it is nothing but quantum. Single packet is quantum. And if the electromagnetic radiation is light, if the electromagnetic radiation is a light radiation, then this quanta or quantum will be converted to photons or photon. Okay, that is the main idea. And the thing is that energy of each packet is fixed. If I am taking this single packet, energy of this single packet is nothing but E is equal to h nu. Energy of this single packet is E is equal to h nu, or E is equal to hc by lambda on expanding the frequency. Okay, this is what Planck's quantum theory, that is quantization of energy. Okay, a single packet will be having energy h nu. If I have packets of energy, it will be the integral multiple of h nu, that is E will be integral multiple of h nu for packets of energy or for quanta. And here what is the value of h? H is equal to 6.626 into 10 to the power minus 34, or in terms of erg it is 6.6 into 10 to the power minus 24 erg. Okay, now for doing the numerical calculations, for doing the calculative part easier, what you can do is, you can take if you are finding in electron volt, instead of hc, you can substitute the value 12400. You can substitute the value 12400 for hc, and remember that lambda should be in angstrom. That is the one thing that you should remember here. Okay, got it? Are you clear with the Planck's quantum theory? Anybody want the summary of it? Are you clear, or am I going too fast? What's your feedback? Is it fine? According to Planck's quantum theory, energy is not continuously flowing. It is flowing in packets of energy, and each packet's energy is fixed. It is equal to h nu. That is only thing. And this single packet we will call it as quantum, and for a packets we will be calling it as quanta. That is the only thing. And the equation Hc, we can give the value as 12400 if 1240 if the in electron volt, if the lambda value is in angstrom. And if you got electron volt, how we can convert it to joule? How we can convert it to joule? 1 electron volt is equal to, can anyone let me know? Yes.
1.6 into 10 to the power minus 9.
Yes, very good. 1.6 into 10 to the power minus what?
19.
19, very good. Minus 19 joule. This is the one thing you should note down. If you got the value in electron volt, you can convert it to joule by using this. So this is all about Planck's quantum theory. If it is clear, I can move to the next part. Are you done? Guys, let me know. Is it enough or do you want more explanation? Yes, thank you for your response. Very good. You can take a screenshot or no worries, I will be sharing this in the group, but annotation won't be there. Yeah, that already you have to, annotations and all, you have to write it in your notebooks, whatever I am writing, because every time it can't be saved in the screen. Okay. Yeah, that was Planck's quantum theory. Now this is one of the phenomena of light in which Albert Einstein got Nobel Prize. Okay, for this only Albert Einstein got Nobel Prize. What is this? Photoelectric effect. And this photoelectric effect can't be explained by considering wave nature of light. Then how we can explain it? By considering the particle nature of light through the Planck's quantum theory. Now I will be explaining it, how the photoelectric effect can be and what are the important points you should note down here. Okay, photoelectric effect, it is a ejection of electron. This is a photosensitive metal. Consider that this is a photosensitive metal. What I will be doing, I will be irradiating light. Through this photosensitive metal. When I am irradiating, what is happening? Electrons will be ejecting out. And this ejection of electrons, when a radiation of suitable light strikes on it, is what we call it as photoelectric effect. Okay, got it? I hope that was clear too. Yes, very good. Now what is photoelectric current? That is what my next question. Is my screen is visible? Properly?
No, sir.
Not that, it's not clear? Okay, I think most of the students it is clear. Okay, or else no worries, I will be sharing this PPT. Now what is photoelectric current? That's my next question. What I will be doing, this setup. In this setup you can see electrons will be ejecting out from here. This is a photosensitive metal. I will be radiating light and electrons will be ejecting out, and this is positive part. This is the cathode. And what is happening? When our electron is ejected, that electron will be moved towards this plate, this positive plate, right? When this moves to the positive plate and when it completes one circuit, what is going to happen? We can see a glow of bulb here. And that current produced due to photoelectrons. This current which is produced due to photoelectrons, right? These are photoelectrons, is called as photoelectric current. Got it? Is it clear? You understood what is photoelectric current? Yes.
Yes, sir.
Yes. Now my question is, how this photoelectric current is related to the photoelectrons and how this photoelectrons is related to the number of photons. That is what my question. So photoelectric current, it is directly proportional to the number of photons. Photoelectric current is directly proportional to the number of photons because photoelectric effect is, I can say photoelectric effect is one photon, one electron emission. Photoelectric effect is one photon, one electron emission, which means a single photon can emit only one electron. That is, if I have a n number of photons, which means n number of electrons will be ejecting out. If n number of electrons will be ejecting out, we will be getting more photoelectric current. Okay, but my question is how we can increase the number of photon? How we can increase the number of photon? What we have to do to increase the number of photons? Anybody have any idea? Very good. Intensity. Intensity we have to increase. On increasing intensity, more number of photons will be coming, and if more number of photons coming, more photoelectrons will be there. Number of photoelectrons. This is about how we can increase the photoelectric current. Now my next question is how we can increase the kinetic energy. How we can increase the kinetic energy? How we can increase the kinetic energy? Kinetic energy means what? Electrons will be ejecting out, and that ejected electron, this is the ejected electron, this ejected electron will move with some kinetic energy, and the kinetic energy of this ejected electron I can increase. How I can increase?
Frequency.
Yeah, frequency. Very good. Frequency or energy. Energy of ejected electron is directly proportional to the energy or frequency of radiation. That is, if I want to increase the kinetic energy, I have to increase energy or frequency of radiation. If I want to increase the photoelectrons, I have to increase the intensity. That is the main point here. Okay, got it? Is it clear, everyone? Now what is the condition? What is the condition for photoelectron? Is there any condition that photoelectron should happen? I have to supply this much energy, then only photoelectric effect will happen. Is there any?
Frequency.
Sorry?
Work function.
Sorry?
Work function.
Yeah, work function. Very good. That is incident energy. Incident energy should be greater than or equal to work function. This is the condition for photoelectric effect to happen. Okay. This is one of the condition. Okay. Now my question is, I have a metal, and this is having a work function psi is equal to 50. Work function 50 joule. What I will be doing? I will be supplying 80 joule of energy. I am supplying 80 joule of energy. That is, I am supplying 80 joule of energy, and how much it is? In that 80 joule, how much the electrons will be accepting? How much the electrons will be accepting out of 80 joule to come out from the surface?
30.
Yeah, 30. The work function of this metal is 50 joule. So if I am supplying 80 joule, how much energy is required to eject out the electron?
50 joule.
50 joule, because the work function is needed 50 joule. And what about the remaining 30?
30.
Yeah, what about the remaining 30? What about the remaining?
Kinetic energy.
Yeah, very good. That will be goes as kinetic energy. So hereby we can make the equation of photoelectric effect. Incident energy is equal to psi for work function plus kinetic energy. So hereby we got the equation of photoelectric effect. This is a very important equation. Question has directly come from this part. Okay, is it clear? That is, only electron will be receiving only that particular energy required to come out from that surface. Remaining will be imparted as kinetic energy. Is it done? Are you okay with this? Shall we move? Yes, thank you. Yes, anybody is feeling any difficulty? Yeah, anybody want me to explain it once again or anything? I think few of you Sanjay Kumar. Sanjay have raised your hand. What is your query, Sanjay? What is your doubt? You simply raised your hand or? Okay. Which part you want to repeat, Dhanashri? Which part you want to repeat? Tell me. You can unmute and you can say, no problem. You have full license to speak in the class. Which part you want to repeat complete or only the photoelectric equation? Okay, I think I will be going to the important part of it. what I am saying is photoelectric effect, ejection of electron from a metal surface. Okay, and number of photoelectrons ejecting out is directly proportional to the number of photons, because photoelectric effect is one photon one electron emission. If I am supplying one photon, if I am supplying a one photon, that will eject only one electron. So more photons if I am supplying, more electrons will be ejecting out, If there is more electrons, the photoelectric current also will increases. Why? Photoelectric, it is a current due to the movement of photoelectrons. How we can increase the number of photons? We can increase the number of photons by improving or increasing the intensity of radiation that I am supplying. That is the first point. Now an electron got energy just to come out from the surface. That is, electron got energy which is equal to the threshold energy, and this electron will move with a kinetic energy if I supply some additional energy or frequency to the radiation, and that will lead to the kinetic energy. That is what I mentioned here. Kinetic energy of ejected electron is directly proportional to energy or frequency of the radiation. That is, if I am increasing the frequency or if I am increasing the radiation, increasing the energy, then kinetic energy is increasing. If I am increasing the intensity, number of electrons ejected will be increasing. That's a 2 point required for this. Okay, there is nothing else. And next is photoelectric equation. Incident radiation is equal to work function plus kinetic energy. That is photoelectric equation. Okay. Yeah, I think this is enough. I can't go much because time is not there. Shall I move to the next part? Yes. Thank you for your response. Yeah, here is the equation for photoelectric effect. Work function is equal to kinetic energy, maximum kinetic energy, and the work function equation. Work function equation is equal to h nu naught. Nu naught is a threshold frequency, and this nu naught I can write as 1 by lambda naught. Lambda naught is a threshold wavelength. Lambda naught is a threshold wavelength. Nu naught is the threshold frequency. Okay, is it clear, everyone? This is only most of the question from the photoelectric effect you can solve with these points. Okay, now we will be moving into the spectrum. We will be moving into the spectrum of radiation. What is spectrum? That is, if I have a light, am having a light, just imagine that I am having a light. If I pass this light through a prism, what is going to happen? If it is a white light, that will be splits into its colors, that is VIBGYOR. It is starting from red ending to violet. Okay, this is the spectrum. This is what we call it a spectrum of white light. Okay, now what we are going to study? Here? We are going to study about the hydrogen spectrum. Before going to hydrogen spectrum, let me tell you what is emission spectrum and absorption spectrum. Listen very carefully, don't lose out the focus, because it's a little bit difficult to understand. What I am doing is, I am having a light of radiation, and what I will be doing is, this radiation will be passing, and I will be putting a gas. Consider this is a gas molecule, any atom or anything, and this radiation will be passing through the gas, and after passing through that, I will be placing a prism over here, and the remaining radiation will be passing through this spectrum, and I will be getting a spectrum here. Now in this spectrum, what is the problem is, most of the lights in this, you won't be getting a continuous spectrum. Why you won't be getting continuous spectrum? Okay, you got a spectrum, but here you are not getting a continuous spectrum. Here you can see some gaps. What are these gaps? These gaps are the radiation absorbed by this gas. And this spectrum we will be calling it as absorption spectrum. is called as absorption spectrum. Got it? Absorption spectrum. Okay. Now what is going to happen? This gas has absorbed some radiation, right? It has absorbed some radiation, and the electrons has excited it to, because of that radiation, electron has excited to the higher level. Electrons has, just a minute. Electron has excited to the higher level, and this electron which has excited to the higher level will come back to the lower level, right? Definitely it will come back to the lower level. When it comes back to the lower level, it will be emitting radiation. The gas which has absorbed some radiation will excite the electrons to the higher level. When the electron has come back to the lower level, it will emit some radiation, and that radiation also I will be passing through a prism. Can I pass that through a prism? Yes, I will be passing through a prism, and after passing that I will be getting a spectrum. After passing that I will be getting a spectrum. In that spectrum what is happening is, whatever the missed radiation here, that will be appearing. That will be appearing over here. Whatever the radiation that has missed there, that will be whatever the radiation that is absorbed here, that will be appearing here, and this type of spectrum we will be calling it as emission spectrum. Emission spectrum. Emission spectrum. This is all about absorption spectrum and emission spectrum. Now if I am just combining these two spectrum, plus emission spectrum, if I am combining this, what I will be getting? If I combine absorption spectrum plus emission spectrum, what I will be getting? What spectrum I will be getting? Yes, give me the response. What spectrum I will be getting if I combine absorption spectrum and emission spectrum? Because whatever the missed radiation is there, that has appeared here. So if I am placing this over here, what I will be getting? I will be getting a continuous spectrum. Continuous spectrum. This is what absorption spectrum and emission spectrum. Got it? Okay, no worries, Anushree, no problem. If you are having network problem, you can put it in the chat box. Because chat box I won't be seeing it all the time, that's why I am saying better you can unmute and you can say. But if you have network issue, you can put it in the chat box, no problem. Okay, so have you understood this one? Is it clear? Absorption spectrum and emission spectrum? Is it? Shall I move? Yes. Okay, yes, thank you for the response. The same thing only I will be explaining that in the next slide. This is the same thing. Here we got an absorption spectrum here because of the absorption of radiation by an atom, and here you can see some of the lines are missing. So whatever the lines that are missing will be coming out when an electron in excited states jump back to the ground level. That is what emission spectrum. And this, on adding these two, I will be getting a continuous spectrum. Okay, that is what all about spectrum. Now we will be moving into the important part, that is the line spectrum of hydrogen. Line spectrum of hydrogen. Okay, line spectrum of hydrogen. We already said you, okay, I am taking a hydrogen atom. and this hydrogen atom is irradiated with some radiation. When I am irradiating hydrogen atom with some radiation, the hydrogen atom electron will be jumping to the higher level, and the electron which is in higher level, they will be jump back to the lower level, right? That is what the hydrogen spectrum. If they jump back to the lower level, n is equal to 1. If they jump back to the lower level, n is equal to 1. We will be calling it as Lyman series. N is equal to 1. And if it is jump back to the level n is equal to 2. If it jump back to the level n is equal to 2, then we will be calling it as Balmer series. And if it is n is equal to 3, it is Paschen series. And n is equal to 4, bracket series. N is equal to 5, Pfund series. And n is equal to 6 also we can write. N1 is equal to 6, it is Humphrey series. Humphrey series. Okay. So this is about the hydrogen spectrum. Now here you can see an equation, wave number, calculation of wave number. Wave number is also inverse of lambda. Okay. Now see here students, what is this wavelength or what is this wave number? Suppose an electron jumps from n is equal to 2 to n is equal to 1. N is equal to 2 to n is equal to 1. We should know the wavelength of the radiation, right? We should know the wavelength of this radiation, right? For calculating that only we have a formula called as Rydberg formula, and it is, by shortening it, I can write as wave number is equal to RH square 1 by n1 square minus 1 by n2 square. Very important formula, in which n1 is the lowest value and n2 is the highest value. Okay. Are you clear with these things? Are you clear with these three things? Are you clear? Just note down, for n1 is equal to 1, it is Lyman series. N1 is equal to 2, it is Balmer. N3 is equal to 3. Sorry, n1 is equal to 3, it is Paschen. Then bracket, then Pfund, then it is Humphrey. Okay. Now one more thing you can see here, ultraviolet, visible, infrared, far infrared, and for Humphrey also it is far infrared. What are these things? I will tell it by taking example of Lyman series. You can see there are different radiations of Lyman series, right? 1, 2, 3, 4, 5. You can see different radiations of Lyman series, right? If I found out the wavelength of the minimum wavelength of Lyman series and the maximum wavelength of Lyman series, that wavelength will be coming in the wavelength range of ultraviolet radiation in the electromagnetic spectrum. I will repeat once. If I take the range of minimum wavelength and the maximum wavelength of Lyman series, that range will becomes in the range of wavelength of ultraviolet radiation in the electromagnetic spectrum. That is what I mentioned, ultraviolet rays here. And for Balmer series, that range of wavelength will be coming in the visible part of electromagnetic radiation. And for Paschen, it comes in the infrared part of radiation. Then bracket, infrared. Pfund also far infrared. Humphrey also far infrared. So this is what this electromagnetic spectrum is telling about. Is it clear to everyone? Is it clear? Or anybody want to repeat it once again? Okay, I hope it's clear to everyone.
Sir, how to calculating maximum and minimum wavelength?
Maximum and minimum wavelength, that I will give you a question also. Maximum wavelength means what? Maximum wavelength means what? Or I am talking about minimum wavelength. Minimum wavelength. Minimum wavelength means what? Maximum energy. We know that energy and wavelength are inversely proportional, right? Energy and wavelength are inversely proportional. So if I am talking about for Lyman series, what is the maximum energy for Lyman series? Lyman series, the beginning, it is starting from n1 is equal to 1. And what should be the n2 value? N2 value should be infinity. N1 should be 1 and N2 value should be infinity. And this wavelength this 1 by lambda value will be telling you, will be giving you the minimum wavelength in Lyman series. Minimum wavelength in Lyman series. And if you ask the same question, what about maximum wavelength? What about maximum wavelength? Maximum wavelength means minimum energy or maximum energy?
Minimum.
Yeah, very good. It's a minimum energy. Minimum energy. What is the minimum energy in Lyman series? What is the minimum energy in Lyman series? Tell me guys. N1 is equal to 1, 2, N2 is equal to
2.
N2 is equal to 2. That's only. Find out the wavelength of this transition and that is the maximum wavelength. Simple. Is it clear, everyone? If it is clear, give me some response. You can say something. It is clear. Yeah. Okay. Yes. Thank you. Now I will be moving to one more part. Okay. This is what I have mentioned. For Lyman series, N1 is shortest. The minimum orbit is N is equal to 1. Then N2 will be 2, 3 and it will go like that. For Balmer it is 2, then 3, 4. Paschen 3, 4, 5 like that. Now another one, number of spectral lines, another important one, number of spectral lines. I will just take an example. Suppose a radiation, N1 is equal, N is equal to 1, 2, 3, 4. Suppose a radiation transits from N is equal to 4, N is equal to 4 to N is equal to 1, N is equal to 4 to N is equal to 1. How many different ways in which this radiation can move from N is equal to 4 to N is equal to 1. First it can directly move from N is equal to 4 to N is equal to 1. Then it can move first N is equal to 4 to N is equal to 3. Then it can move to N is equal to 1. Then 4 to 3, 3 to 2, then 1. Any other possibility? Okay, and then 4 to 2, then 2 to 1. These are the different possibility in which a radiation can transit from N is equal to 4 to N is equal to 1. Right. Now how many are there? Now how many transitions are there? You can see. Okay, there is 1, then 2, 3. These two are repeating. So 4, then 5, then 6. You can see total 6 lines are there. Total 6 lines. 6 lines. Which are these lines? 6 spectral lines are there. There are 6 spectral lines are there. And finding the spectral lines, finding the spectral lines by using this method is very difficult. So we have an equation to find out the total spectral lines, that is N2 minus N1 into N2 minus N1 plus 1 divided by 2. This is the equation we are using here. Got it? Now we can verify that also. Here N2 is what? N2 is equal to 4 and N1 is equal to 1. We can check with the equation. 4 minus 1 into 4 minus 1 plus 1 divided by 2. What I will be getting? I will be getting answer 6. So same thing I got it. For this it is easy to draw and find out, but if you got a higher level transition, then it will be difficult. Okay, that is what spectral lines. Clear? Are you clear? Now one more thing I want to say. Okay, we got 6 lines, right? We got 6 lines. Among these 6 lines, how many lines are falling in? How many lines are falling in the Balmer series? How many lines are falling in the Balmer series among these 6 lines? You can see 1, 2. 2 lines are falling in the Balmer series. How we can find out that one? That is also by using an equation. Number of lines falling in a particular series. How we can find out? That's by using the equation N2 minus ground state of that series. N2 minus ground state of that series. Okay, we can verify that. How we can verify that? Okay, if I'm taking this transition n is equal to 4 to n is equal to 1, how many lines are falling in the Balmer? We can see 2 lines are falling in the Balmer, right? So that we can verify by using this equation. N2 is equal to 4, then minus ground state of Balmer 2. We got it. So this is another point. I want all of you to take a note of it. Is it done, everyone? Number of spectral lines, and among these spectral lines, how many lines are falling in a particular series? That is what the 2 points I want to convey here. Shall I move? Guys, are you there? Sorry? I can move, right?
Please wait a minute.
Okay, yeah, sure. No worries. Yes, these are some important points. Whenever I am writing, write it along with me so that we can save the time. Okay. And one more point I want to note down is limiting line. Limiting line is what the question someone has asked. That is shortest line, or it is also called as series limit. Series limit. Series limit is the shortest wavelength, and shortest wavelength in any series is n2. For any series, the n2 will be infinity, and the n1 will be the ground state of that particular series in which you want to find out the shortest wavelength. Okay, series limit. Can I move? Are you guys tired?
Yes, sir.
Okay, you are tired.
No, sir, you can move.
Okay, thank you. What about others? Can I move? You guys are feeling too much stressed, tired? Yes. Okay. Are you guys are listening, or like just simply switching on the camera and sleeping or something? Because I used to do this. Okay. I know that you all are. Yes. So all of you are very much dedicated students, right? So I know you will be attending it very focusfully. Yes. Thank you. Okay, now one more point I want to say. Okay, before going to that question, okay, yeah, everything has been done. Now I will be giving a question. I know it's a little bit boring. To avoid your boring, I am going to give a question. NEET 2025 question. I want everyone to solve this question and get me the answer fast. Yes. If anybody got the answer, you can put in the chat box, or you can unmute. Yes. Let's see who is going to give me the answer first. Yes, come on everybody. Let's have some healthy competition. We already have discussed this equation. It undergoes from n is equal to 2 to n is equal to. Okay, what is asking in the question? Wavelength. Wavelength is asking. What is the equation you have to use for calculating wavelength? 1 by lambda or
1 by 4.
1 by 4. Yeah, I got answer from who has given the answer? Prathamesh, right? Okay. Yeah, what about this? What's your answer? 1 by 4. Then anyone else having different opinion? No, right? Any other answer anybody got? Let me check the chat box. Yeah, okay, Srishmi has given the option A. Okay. Anyone else? Anyone else is having? Supriya saying, sir, this video recording will be available in YouTube channel. Right now it is not available, but we'll be uploading it, but don't know when it will be uploading and all. Try to be maximum in the live class only, because it will take some time to be uploaded in the YouTube. By that time your exam will be, don't know, maybe your exam will finish or not. Maximum try to be in the live class so that you can ask doubt and everything. Yes, Gayatri, you were saying something? We will upload
1
today.
by 4, sir. 1 by 4.
1 by 4, yeah, 1 by 4. I 3 from one say 1 by 4. Yogesh is saying option D. Okay, we'll see. We can solve it. I think we are getting multiple answers, so it should be solved in the class. So the equation is 1 by lambda is equal to wave number, which is equal to, what is the equation? RH into Z square into 1 by N1 square minus 1 by N2 square. First I am going for the transition. N is equal to 2 to N is equal to 3. So 1 by lambda value is what? RH, and as it is hydrogen, Z is equal to 1. 1 by N1 is equal to 2 square, it is 4 minus 1 by N2, it is equal to 9. On solving this, what we are getting? 1 by lambda is equal to, what is the answer you are getting here? I think 5 RH divided by 36, or lambda is equal to 36 by 5 RH, lambda 1. Now for the second transition, that is N is equal to 4 to N is equal to 6. Yeah, 1 by lambda is equal to RH into 1 by 4 squares. 1 by 4 square is what? 16 minus 1 by 36. On solving this 1 by lambda value, what we are getting? What we are getting the 1 by lambda value?
144 upon 5.
Sorry, 5?
144 upon 5.
144 RH divided by 5, right? Is it? Is it what everyone got? Is it or not? Okay. Okay, then the lambda value will be 5 by 144 RH. Okay, this RH will be in the denominator. Is it what everyone got? Lambda 1 and lambda 2? Is it what everyone got? If that is the case, give me some thumbs up. Yes. The lambda 2 is not 5 by 1 by lambda value is 5 by, okay, let me check it. Okay, 1 by lambda value is 144, okay, correct only, 5 RH, and lambda 2 is equal to no 1 by lambda value is 5 RH divided by 144, and lambda 2 is 144 divided by 5 RH. I think this is the correct one. Yes.
Sir, I am telling direct answer.
Oh, you are telling about direct answer. Okay, yeah, correct only. So lambda 1 by lambda 2, what do you have to do here? Okay, what is lambda 1 by lambda 2? That will be coming as 5 is getting cancelled. It will be 36 divided by 144. It is equal to 1 by 4. Yes, here is the answer for the question. Is it what everyone got? Is it what everyone got? Yes. Yes. Okay, so this is an easy question. We can take a screenshot and we can move. Okay, done. Shall I move? We have to cover a few more topics here. Done. Shall I move? Tell something. Hi, bye, something. Yes. Yeah, next the important part, Bohr model of atom. I want everyone to take note of all the important points, important equations in this one. Bohr model of atom. What is Bohr model of atom? There will be a nucleus. And the nucleus will be surrounded by electrons. Surrounded by electrons in a fixed circular path. We will be calling it as orbit. That is what Bohr model of atom. And the angular momentum of the circle is fixed, and it is integral multiple of NH by 2 pi, H by 2 pi. That is MVR is equal to H by 2 pi. Now the point that you have note down is how we can calculate the radius of this orbit. How we can calculate the radius of orbit in which electron is revolving. That is equal to 0.529 into n square by z in terms of angstrom. 0.529 into n square by z in terms of angstrom. In terms of picometer, it will be 52.9 into n square by z. Now velocity it is 2.18 into 10 to the power 6 into z by n. Another important one. If they have asked velocity, this is how you have to find out. Then energy is equal to minus 13.6 electron volt per atom, and it can ask in joule also. For joule it is minus 2.18 into 10 to the power minus 18 into z square by n square joule per atom. Okay. Yeah, that is, these are important equations that you have to remember. You should not forget it at any cost. That's very important. Okay, now there is a relation between energy, potential energy and kinetic energy. What is the relation? Kinetic energy will be equal to minus of total energy, which is equal to potential energy by 2. This is another one in which a question can come. They will be giving kinetic energy or potential energy, and they can ask what is potential energy or total energy. So this is the equation, you have to note it down. Done. This is the summary. This is the complete summary of Bohr atomic model. You can completely trust on this equation. No more question will come beyond this. Shall I move? Are you done? Take a screenshot. Move it. I think already you know these equations and all. If you already have this equation, no need to write it. Okay, we'll be moving it. Next one is calculation of ionization energy. Question can come, calculate the ionization energy of a particular atom. How you will be finding it? Ionization energy is when an electron is being removed from the ground state, n is equal to 1 to infinity. Here it is fixed. Ionization energy is fixed, that is from n is equal to 1 to n is equal to infinity. That is what ionization energy. We will be using the equation minus 13.6 into z square by 1 square. That is E infinity minus E1, higher energy minus lower energy. And for hydrogen like species, the ionization energy is nothing but the energy of the first orbit, 13.6 into z square electron volt. Now another question will be separation energy or binding energy. What it is? Here some relaxability is there. Energy required to remove an electron from any excited state to infinity. Here ground state will be either 2, 3 or anything, and the higher level state, higher energy should be infinity. That is what separation energy or excitation energy. Okay, just again have an understanding of what is ionization energy, what is separation energy. Separation energy is to separate from any orbit to infinity. Ionization energy is from n is equal to 1 to infinity. Now failure of Bohr model, it can explain only for one electron species, and it cannot explain Zeeman effect as well as Stark effect. Okay, all these things are on the slide. Now we can move to the next part. Shall we move? Yeah, okay. Just no need to write complete thing in the board. Ionization energy, n is equal to 1 to n is equal to infinity. Separation energy, n can be anything, and the next higher level energy will be infinity. Okay, done. Gayatri but is raising the hand. What happened, Gayatri? Do you have any doubt?
Sir, ionization energy will not change.
Ionization energy will change depending upon the atomic number. Here you can see the atomic number is there. Z is atomic number. For hydrogen it will be 13.6, but it will be different for helium and different for lithium and for other. N1 and N2 value will be fixed there. Got it? Yes. That is energy of the first orbit. That is what ionization energy. Energy of first orbit of an atom. For hydrogen, energy of first orbit is 13.6. For helium it is different. Lithium it will be different. That's only. And for hydrogen it is minus 13.6. So we have to supply plus 13.6. Then only we can make the energy of that particular orbit 0. We want to make the energy of an orbit 0, then only we can remove an electron from that orbit. Got it? Yes. So I am moving. Shall I move to this slide? Yes. Next one, the de Broglie. Yeah. Now the confusion comes. Particle nature or wave nature? Some of phenomena is explained by using particle nature, but some are explained by using wave nature. What is actual nature? What is actual nature? Actual nature is both. That is, if any particle having any mass, if they moves from one distance to another distance, it have wave character also, some kind of wave character is also associated with it. That is what mentioned here. A particle which is having some wave character also associated with it, any particle. And depending upon the mass, which nature is more sounded? Which nature is more sounded, that is depending upon its mass. If mass is very less, then wave nature is more sounded, or wave nature will be more. If mass is higher, then wave nature will be very less. That's the only thing. And you have to note down few equations. That is only you have to do here. The important equation. First one is lambda is equal to h by p. That is, wavelength is inversely proportional to mass and volume. And next is relation with the kinetic energy. This is the board is clear? Kinetic energy is part is clear? Okay. For kinetic energy, lambda is equal to h by root 2 m kinetic energy. Root 2 m kinetic energy. And in relation with the Bohr model. Bohr model, 2 pi r is equal to n lambda, where Rn or r is nothing but our radius of nth orbit, 52.9 into n square by z picometer. Have you taken note of these three equations? Lambda is equal to h by p, lambda is equal to h by root 2 m kinetic energy, 2 pi r is equal to n lambda. Are you done? Done? Yes. Okay. If I want to move, I need some positive sign from your side. Okay, I think I can move. Chalo. Yes. Next one is Heisenberg's uncertainty principle. For uncertainty principle, I am not going to deep. Uncertainty principle is all about whenever we want to find out exact position and momentum of an electron, it is impossible. Why it is impossible? Because when we try to find out the exact position, then the momentum will be changing. When we try to find out momentum, position will be changing. That is what uncertainty principle it is. And so it is not possible to find out position and momentum exactly and simultaneously at a time. So what do you have to do in this part? Note down the equation, all the equations of Heisenberg's uncertainty principle. Delta x, change in position, into delta p, change in momentum, is greater than or equal to h by 4p. This is the one of the equation. Now delta p, I will be expanding it to m delta v. Delta p is mass into velocity, right? So m delta v greater than or equal to h by 4 pi, or delta x into delta vx is greater than or equal to h by 4 pi m. M I have taken to the right hand side. Now another equation in which you won't be that much familiar is in terms of time and energy. That is delta E into delta T is greater than or equal to h by 4 pi. Time and energy. These four equations I want everyone to take a note of it. Questions has come directly from this equation. I will give you that question. Are you done? Are you done, my dear students? Shall I move? Or do you want to go for lunch? Are you guys hungry? I am a little bit hungry. No worries, I can wait. You also have to wait. Yes. Chalo. Okay. So Heisenberg's uncertainty principle is over. Now the last part, not last part, second last. Quantum numbers. Quantum numbers. What is quantum number? Quantum numbers are the address. Quantum numbers are the address. What is address? If I am telling you what is your address, you are belongs to India. In India you belongs to Karnataka. In Karnataka belongs to, okay, Karnataka maybe you will be belongs to Hassan. In Hassan you belongs to the Mavanagiri, Hassan JNV. So these are your address, right? Like that, an electron in an atom is also have some address. To know about the address of or the position of an electron, we should know some details of it. These are those details. What are those details? They are quantum numbers. First I will be finding the principal quantum number of an electron, and its value can be n is equal to 1, 2, 3 to infinity. N is equal to 1, 2, 3 to infinity, and this principal quantum number will be telling you about the size and energy of a electron in an orbit. If n is equal to 1, it means it belongs to the K shell. It belongs to the K shell. That is the country, we can say. Country is K shell. If n is equal to 2, it belongs to the another country, that is L country. Like that. Got it? And now we know that every country is divided into different states. So here also this country, that is principal quantum number, is divided into different states. Which are those states? That is azimuthal quantum number. Azimuthal quantum number L. And the number of states will be from 0 to n minus 1. 0 to n minus 1. That is, if a principal quantum number n is equal to 3, how many azimuthal quantum number value will be there? 0, 1, 2. 0, 1, 2 is the azimuthal quantum number. That is, this represents which shell? M shell. M is my country, and this M country have how many states? 3 states are there. 3 states are there. What is the name of the first state? For 0, each azimuthal quantum number is representing a subshell. And what is the name of this subshell? A subshell. For 1 it is P subshell. For 2 it is D subshell. Got it? This is about the relation between principal quantum number and azimuthal quantum number. Got it? Okay. And
So sir, L equals to 3 and 4.
yeah, n is equal to 3 and sorry?
For L equals to 3 and 4, which orbit?
For L is equal to 3 and 4, the principal quantum number should be 5. If principal quantum number n is equal to 5, what are the L values? 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. And this is S, this is P, this is D, this is F, and this is G, which are not that much pronounced. Okay. Got it? That is, number of L values are from 0 to n minus 1. Here it is 3, so it will be 1 less than the number 3. Okay, got it? Any other doubts? Is it what you asked?
Yes, sir.
Okay. Yes. Now another point I want everyone to take a note of is angular momentum. Azimuthal quantum number will defines the orbital angular momentum, and orbital angular momentum value orbital angular momentum value capital L is equal to root of L into L plus 1 h by 2 pi. This is an important equation. Question has been asked directly. Take a note of it. Okay. Can I move to the next quantum numbers? Can I move?
Yes.
Yes, thank you. Now magnetic quantum number. Now we have studied about subshell, which is azimuthal quantum number, and this subshell is also divided into few orbitals. Like every state, it is divided into different districts, right? Like that, our subshell is also divided into orbitals. And how we can find out the orbitals? Minus L to plus L is the orbital values. That is, if I have n is equal to, not n, if I have L is equal to 2, how many, okay, not 2, L is equal to 1, how many magnetic quantum numbers are there? That is a state, the name is L is equal to 1, which is P. The name of this state is P, and this state is divided into different district, and that district only we are going to find it out. How we can find out the district? The value of district will comes minus L to plus L. That is, minus means minus 1, 0, plus 1. These are the 3 orbitals of this particular subshell. So minus 1 represents one orbital, 0 represents another orbital. This is Px, Pz, Py. Got it? Have you got it? How we can find out magnetic quantum number from azimuthal quantum number? Okay, yes.
Sir,
Yes.
if n is given 2, then
N is?
n is equal to 2.
Okay, if n is equal to 2, then L value will be 0 and 1. L value is 0 and 1. And what is a L value? ML value for 0 is what? Minus 1 to plus 1, right? And here there is only 0, so it is 0 only. There is only one orbital. L is equal to 0 means S orbital, right? S subshell has only one orbital. Now for L is equal to 1, it is P subshell, and P subshell have how many ML values? Minus 1, 0, plus 1, like that, 3 ML values. Got it? Is it clear? Is it clear, Gayatri? Or is it the doubt that you are asking?
So here it is 4 ml values.
4? Sorry?
Only ml p subshell is different.
Only P subshell is? I didn't get you. Only?
Only p subshell is taken as ml value.
No. For S subshell also ML value I have taken. That is 0 only. ML means S orbital. S subshell have only one orbit, right? P orbital have 3 orbital.
Each subshell will have different.
Each subshell will have different. If I am taking for D, that is, if n is equal to 3, L value will be 0, 1, 2, 0, 1, 2. And for this is L is equal to 1, and this is this L is equal to 0. This is having ML value 0, only one orbit is only there. But this one is having ML value is equal to minus 1, 0, plus 1. 3 orbits are there. And for this L is equal to 1, L is equal to 2. Have how many ML values? Minus 2, minus 1, 0, plus 1, plus 2. That is how many orbitals? 5 orbitals are there. That is, yeah. Is it clear? Any doubt in this?
Yes.
Okay, thank you. Yeah, that was about magnetic quantum number. Now spin quantum number. Spin quantum number, it is already an electron in an orbit can be in positive spin as well as negative spin, which means it can be either in clockwise rotation or it can be in anti-clockwise rotation. Actually, telling that clockwise and anti-clockwise is not actually exactly correct. What actually it is meaning is, plus half and minus half is telling that these two electrons in an orbit is in two quantum mechanical state. It is in two quantum mechanical state. To tell that they are in two different quantum mechanical state, only they are mentioning plus half and minus half. Plus half is a one quantum mechanical state and minus half is another quantum mechanical state. It's not like actually one is clockwise rotating, another one is anti-clockwise rotating. Okay. Yes, so we have discussed about all the 4 quantum numbers, Now we can solve some questions. Okay, we'll see questions are there, or else we can move to the next electronic configuration part. Shall I move? Okay. Okay, just I want to note down this one also. Question can come, that is, how many electrons can be there in a particular shell? How many electrons can be present in a particular shell, that is 2n square. How we can find out the total number of electrons present in a shell, that is 2n square, and how many subshells are there in a particular shell? How many, maximum electrons in a subshell, that is 2 into 2l plus 1. This formula, if you remember, you can solve many questions within a very less number of time. You can solve it without this equation also, but it will take some time. If you want, you can verify it. That is, I am taking shell n is equal to 1. I am taking shell n is equal to 1. N is equal to 1 will be having L value is equal to 0, right? Which means S orbital and S subshell. And S orbital have how many electrons? 2 electrons. 2 electrons. So that we can verify using this equation. 2 into 1 square, that is 2. We got it. Like that we can verify the subshell also, and number of orbital also, and number of orbitals in a particular subshell, 2l plus 1 value. Take a note of it. These equations are important. Number of orbitals in a particular shell. Are you done? Are you done with this equation? If so, we can move. Okay. Can we move? Okay. We have only 50 more minutes time. One more topic, then PYQ. Yes. Okay. Chalo. Yes, next one is radial node and angular node. Just take a note of these equations. Radial node and angular node, they are nothing but the space or region in which absence of electron. How to calculate the radial node? The equation n minus L minus 1. The equation n minus L minus 1 will tell you radial node. Angular node is nothing but the value of L itself. And total node equation is n minus 1. Just note these 3 equations. You can answer many things. Total node is sum of radial node and angular node. Radial node equation is, what is the radial node equation? N minus L minus 1. Angular node value of L. On summing up, we will be getting n minus 1. Yes, do it. Done. Give me thumbs up if you are done, or give me some emojis about what you are feeling at this moment. Are you happy, excited, sad, tensed? Oh, happy, feeling laugh. Yes, different emojis. Okay, some are confused. Okay, good. Yes, okay. I can't see your face, but I can understand your emotions through your emojis. Yes, great. Now, I hope all of you have done this one. Now, I will be moving into the next part, that is orbital filling and electronic configuration. Another part, the last part is over. Now, we know that electron will be in a particular orbit, particular subshell, particular shell. Now, how we can arrange these electrons? That is by using this principle. First one is Aufbau principle. In Aufbau principle, what we have to note down is N plus L rule. N plus L rule. What is N plus L rule? N plus L rule will tell you how the energy of orbitals are arranged. Lower the N plus L value, lower will be the energy. If the N plus L value is same, then we have to give preference to the one with the higher N value. Higher N value will be having highest energy. First you have to go for N plus L value. If N plus L value is same, then you have to go for N value. higher the n value will be having highest energy. Okay, that is if I am taking for 2p, what is n plus l value? N is 2, p value is 1, it is equal to 3, n plus l value. Now next one is Pauli's exclusion principle. According to Pauli's exclusion principle, no two electrons in an atom have same set of all 4 quantum number. And electrons in a single orbit, an electron in an orbit is differentiated by the 4th quantum number, that is spin quantum numbers, that is 2 electrons. That is what Pauli's exclusion principle is saying. Now Hund's rule of maximum multiplicity. What Hund's rule is saying is that pairing will be starting once all are half filled. That is what the easiest explanation of Hund's rule. But actually Hund's rule you should understand by using the Hund's rule of maximum multiplicity equation. What is that maximum multiplicity equation? What is that maximum multiplicity equation? Modulus of 2s plus 1, and s will be the total spin, and we have to take the modulus of total s. S is equal to total spin. This is using the maximum multiplicity equation only. You have to arrange the electron. Example, I can say 2p3. 2p3, that is p orbital. I can arrange these 3 electrons like this, or I can also arrange these 3 electrons like this. Among these, which arrangement is correct? First one or second one? Tell me in the chat box. First one. Why first one is correct? Why first one is correct? Because first one is having highest spin multiplicity, maximum spin multiplicity. I can check that one. What is S value for the first? We have to find out the modulus of S value for the first one. What is S value for the first one? This is half, this is half, this is half. What it is? Half plus half plus half, it is equal to 3 by 2. And what is S value for second one? Minus half plus half and plus half, which will be equal to 1, right? And then what is the 2s plus 1 value? 2s plus 1, what it is? 2 into 3 by 2, 2 into 3 by 2 plus 1, it is equal to 4. And the second one's 2s plus 1 value, what it is? 2 into 1 plus 1, what it is? 3, right? So among these, highest spin multiplicity is for the first one. That is why the first electronic arrangement is the correct electronic arrangement. Got it? Done? Are you all are clear with this? Yes. So the important topics are all over. I hope everyone got a clear idea about this chapter. Now we will solve some questions about this chapter. And as questions I will be also sharing in the group. You can practice it by yourself. Got it? Shall I move? Shall I click here? Okay. Here is the first question for you. Quantum numbers of 4 electrons are given below. Yeah, now it's a competition. Who is going to give me the answer first? Quantum numbers of 4 electrons are given below. The correct decreasing order of energy of these electrons. Correct decreasing order of energy of these electrons. NEET 2024. Tell me, which equation you have to use? Yeah, who is going to tell me which equation we are going to use here? Who is having that much dare to say? Tell me.
Option B.
Option B. Okay.
Option B.
Okay, Prathamesh is saying option B. Any other option? Second option. Okay. Hanuman Gaunda is also saying option B. Okay. We can see whether option B is correct or wrong. What we have to do here? Which formula we have to use? Aufbau principle. N plus L rule. N plus L rule. What is N plus L value? What is n plus value for the first one? Okay, it's not n plus L value. Okay, sorry, I didn't read the question properly. The quantum numbers of okay, n plus L value only. N plus L. What is n plus L value for the first one? It is 6. Second one, 5. Fourth one, 5. Yeah. The last one, it is 4. So among these, which is having highest? One will be having highest. Then there are two orbitals are there with 5. Among these, we have to consider which is having highest principal quantum number. So third one is having highest principal quantum number. So the next highest will be third, then second, then fourth. This is the order. Got it? Everyone got it?
Yes, sir.
Okay, now I just missed one point. For one electron species like hydrogen, what is the order of energy? The energy order is based on n value alone. For one electron species like hydrogen, the energy order is based on n value only. That is, for one electron species, I will write the energy order. 1s is having less energy, then 2s is having equal energy to 2p, then 3s, 3p, and 3d, like that it will go. This is one I want to note down. Remaining for 2, 3, 4. For all other electron species, the n plus L rule will be applicable. For one electron species, n rule will be applicable. Take a note of it. Question has come from this part. Done, everyone? Got it? Made the note? Yes.
2 minutes.
Okay.
Okay, sir.
Okay, thank you. Shall I move for the next question? Okay. Another question. In hydrogen atom, the de Broglie wavelength of an electron in the second Bohr orbit is, that you have to find out. De Broglie wavelength and who is that guy? Bohr orbit. How they are related? Their relation also I have mentioned in the class. If you remember, you can easily find the answer. Yes. Now the time starts. Who is going to give me the answer first? Option A, B, C, D. What's the answer? Nobody? People are leaving. You guys want to leave? You are feeling hungry? Okay.
Option C.
Option C, very good. Option C is the answer. Which equation you will be using to solve this? Which equation? N lambda is equal to 2 pi r n. N lambda is equal to 2 pi r n. And here you will be finding the lambda, which is equal to 2 pi r n divided by n. And how you will be finding r n value? 52.9 into n square by z. 52.9 into what is n value? 2, that is 4, which is nothing but 211.6. Right. Now I want to substitute in that one over here. 2 pi by 2 into 211.6. You will be getting the answer 211.6 pi picometer. Got it? Is it? Everyone?
Yes, sir.
Okay. Okay. Here is another question, the last question. I want everyone to solve this, and I will be telling a small concept also for this question. Yes. The Balmer spectral lines for hydrogen atom with the lowest energy is located at 5 divided by 36 RH centimeter inverse. Is it correct or wrong? That is not my question. Second one is about black body radiation. I will tell you a small idea about black body radiation so that you can solve this question. What is the question? Balmer spectral line for hydrogen atom with lowest energy is located at 5/36.
Correct, sir. Statement 1 is correct.
Yes, it's correct. Very good. What is the lowest energy? What is the value of N1 and N2 here? What is the lowest energy of Balmer? Lowest energy of Balmer is N1 is equal to 2 to N2 is equal to N2 is equal to
1.
Balmer. N2 is equal to 3. That is Balmer. Lowest energy is 2. Then next highest will be 3, 4. But we need the lowest energy gap, that is between 2 to 3. On solving this, you will be getting the answer 5/36. You can solve it. I am leaving it for you. You can solve that. You will be getting 5/36. Got it? Got it? Now what about black body radiation?
What about the statement 2?
Yeah, what about black body radiation? That I will tell you. I will tell you the relation between temperature and wavelength of black body. I am taking a black body. Okay, suppose this is my black body. Let's suppose this is an iron rod. This is an iron rod. I am going to heat this iron rod. When I am heating this iron rod, what is the color that you can see? Let's suppose I am heating it with a temperature T1 for 100 degrees Celsius. What is the color you can see? First it will become red, right? First it will become red. Yes or no? Yes, it will become
Yes, sir.
red. And after some time, I am giving the temperature T2. And suppose it is 200 degrees Celsius. Again, if I heat with a higher temperature, what is going to be the color? You can see. Okay, yeah, it will become blue or some other color. Now see the wavelength of this one. Which one's wavelength is higher and which is wavelength is lower? For higher temperature, I got lower wavelength. For lower temperature, I got higher wavelength. Got it? This is what black body radiation. This is only about black body radiation, which means the relation between temperature and wavelength is 1/lambda. Higher will be the temperature, lower will be the wavelength of radiation emitted. Now can you tell me the answer?
Answer is both are statement true.
Yeah, when temperature of black body increases, maximum of the curve shifts to the shorter wavelength. Yes, that is correct. I hope black body radiation you got an idea. Relation between temperature and wavelength. Yes. So that's all about today's class. Remaining questions we will be doing it in the next class, because next class we will be discussing the chapter periodic property, which is a small chapter, and here few more questions are remaining that I will do. After that we can move into the next chapter, periodic properties chapter. So hope all of you are fine with today's class. I know it's time for lunch. All of you have your lunch. Come at 3 o'clock for your biology class. Study well, do it well. Yeah. Thank you everyone.